Hey guys, Mr. Kelly here. If you're struggling with your homework this weekend, then this video is just for you. This video is going to address the three different types of problems you come across in the homework assignment for this weekend using the quadratic formula. Now remember, we can only use the quadratic formula if our quadratic equation is in standard form. Standard form is right here. ax squared plus bx plus c equals 0. We have to put our quadratic equation into standard form in order to be able to apply the quadratic formula to it. Let's take a look at a problem. So this problem here is already in standard form. So this is all set up for us. This one is good to go. So we need to first identify our three coefficients. Our quadratic coefficient, which is a, our linear coefficient, which is b, and our constant term, which is c. For this quadratic equation, our quadratic coefficient is 4, our linear coefficient is -8, and our constant term is 1. There's our quadratic formula for those of you who are still having trouble memorizing it. So now all we have to do is substitute our three values in. So we have -8 plus or minus the square root of -8 squared minus 4 times 4 times 1, all over 2 times 4. Again, next step is just crank away the algebra. -8 times -8 is a +8 plus or minus the square root of -8 squared is 64 minus, let's see, 4 times 4 is 16 times 1 is still 16, all over 2 times 4 is 8. We can simplify this down again by taking care of what's underneath the radical into 8 plus or minus the square root of 48, all over 8. Now let's take a look at the square root of 48. Can we simplify that? 48 is just 16 times 3, so we can. So let's factor this down. We get 8 plus or minus the square root of 16 is 4. Radical 3 stays inside, and this is still all over 8. One last step. We can take a look at all three of these monomials here. We have 8, 4, and 8, which all share a common factor of 4. So we pull out a 4, and we get 2 plus or minus the square root of 3, all over 2. Final answer. Now let's take a look at a quadratic that's not in standard form. So instead of identifying our three coefficients first, we need to move some values around here to put this quadratic in standard form. So it looks like the easiest way to do this would be to just subtract a 2v here from both sides. Less work the better, right? So this would leave us with, I'm just going to rearrange this and put the quadratic term first. -5x squared. -8v minus another 2v is a -10v. And 3 is still just +3 equals 0. This guy is in standard form, so now we can just identify the coefficients of all of our terms. Our a value here is -5, our b value is -10, and our c value is +3. There's a little snippet of the quadratic formula again. So now we just substitute our values in. -10 plus or minus the square root of -10 squared minus 4 times -5 times +3, all over 2 times -5. So let's simplify this down as much as we can quick. -10 times -10 gives us a +10 plus or minus the square root of -10 squared is 100 minus 4 times -5 is -20. -20 times 3 is a -60. And for our denominator, we have 2 times -5 gives us a -10. Let's simplify what we can under the radical here, because that's all that we can simplify right now. We still have a 10 out front here, plus or minus. 100 minus negative 60 turns into 100 plus 60, so this is the square root of 160 all over 10. That's a negative 10. So now the next step would be to take a look at our 160 here, right underneath the radical. Can we simplify this? Well, I see a 16, and 16 is a perfect square, so let's factor out a 16, and 16 times 10 is 160. And that looks like as good as it's going to get. So we have 10 plus or minus. The square root of 16 is 4. We still have a radical 10 left inside here. And this is all over negative 10. Now, if we take a look at all three of our monomials here, we have a 10, we have a 4, and we have a negative 10. So we can definitely factor out a 2 because all those numbers are even. So 10 divided by 2 gives us a 5, plus or minus 4 divided by 2 gives us a 2. Radical 10 stays the same. All over negative 10 divided by 2 is a negative 5. And that's as good as that one gets. The last problem you face in your homework uses the discriminant. Now remember, the discriminant refers just to the piece in red here that's underneath the square root symbol. So you're looking just at b squared minus 4ac. Now the sign of this term determines how many roots and what kind of roots we have for our quadratic. So first things first, let's take a look at our problem here, and this is not in standard form, so we have to do some algebra quick. Let's subtract a 5n from the right side and add a 5n to both sides here, minus 5n plus 11. The 8n squared doesn't change, so that just comes right along for the ride. Negative 4n minus 5n is a negative 9n, and 2 plus 11 gives us positive 13 equals 0. Now we're in standard form. Now we can identify all three of our coefficients. Our a value here is 8. Our b value is negative 9. And our c value is positive 13. So now we're just going to use the discriminant to identify how many roots and what kind of roots this quadratic has. So our b term is negative 9. We're going to look at negative 9 squared minus 4 times 8 times 13. Negative 9 squared gives us a positive 81 minus, let's see here, 4 times 8 is 32, and 32 times 13 is some monster number that's much bigger than 81. So we know here without doing any arithmetic at all that our answer is definitely going to be negative. When you multiply all these together, we get 416 here, and 81 minus 416 gives us a negative 335. So all that matters from this part of the equation is that our discriminant is negative. Now this tells us that whatever's under the square root here has a negative in it. It's negative 335. So this term means that we're going to have to pull out an I, square root of 335. Now it doesn't matter if we simplify this down, because the question is just asking us to use the discriminant to identify how many roots and what kind of roots we have. So we had to pull out an I, so we know that we have 2 imaginary roots. And the reason we have 2 imaginary roots is because we still have a plus and minus in front of this term here in our quadratic formula. So we're still adding and subtracting, which means we're going to have 2 possible answers. We also know that the graph of this thing is going to look something like this, or like this, or like this, or like this. It's never, ever going to touch the x-axis here because our roots are both imaginary. Now remember guys, there's three possible values you can have for the discriminant. When this is all said and done, you can have it greater than 0 or positive. You can have the discriminant equal 0, or you can have the discriminant less than 0, which is negative. When the discriminant is positive, that means that this parabola here hits the x-axis at 1, 2 places. So anytime you're positive under the discriminant, you're going to have two real solutions. Anytime your discriminant equals 0, that means that your plus or minus term pretty much just disappears. So you're left with one real solution. And the last case, which we just looked at, is if your discriminant is negative or less than 0. If anything underneath the square root is negative, that means you have to factor out an I, which means you have two imaginary solutions. So these are the three cases you can have. You either hit the x-axis 2 times, if it's positive or greater than 0. You hit the x-axis 1 time if the discriminant equals 0, or you don't hit the x-axis at all if your discriminant is less than 0, because you have an imaginary number involved in your answer. Hope this helped.